In this video, we're going to look at the logical operators that we can use with conditional expressions. So there are times when we want to test two or more conditions. And when we do that, we use something called a compound conditional expression. And basically, it's two conditional expressions like we talked about before, joined by an operator. Now, we've talked about arithmetic operators. Now we're talking about logical operators. And logical operators are something that can join two conditions together to test them both. And basically, each condition is evaluated on its own. And then we have these conjunctions that join them and determine what the overall expression will be. So if we use the AND operator, which is signified by a double ampersand, that is above the 7 on your keyboard. So an AND operator would return true if both the expressions are true. So we'd have an expression on the left that we could evaluate as true or false, and an expression on the right which we can evaluate as true or false, and will cause those two expressions to be joined together. And the only way the overall thing will be true is if both the left and the right sides are true. An OR uses the pipe symbol, and you can find the pipe on the key right above your enter key. If you hold shift, it's the backslash key and the pipe key. So you hold shift and hit that key and you get this vertical called a pipe. Double pipes are the OR logical operator for JavaScript. And that means when you have an item on the left of an OR and an item on the right, if the left side or the right side is true, the entire expression will be true. Okay, so one or the other, where this one where the AND requires both, this one requires just one of them to be true. And then we have the NOT operator, which is an exclamation point. And basically, the NOT operator says take whatever follows it, and if it's true, make it false. If it's false, make it true. It reverses the value of a Boolean expression. So let's look at some examples. So up here, we are using the AND operator, and we're testing an expression on the left side and an expression on the right side. So this Boolean expression on the left is if age is greater than 17. That could be true or that could be false. And on the right side, we're testing score is less than 70. That could be true, that could be false. Overall, the entire statement would only be true or false if the left side is true and the right side is true. So say the person was 18 years old and had a 50 for their score, the entire thing would be true. Because this side would be true because 18 is greater than 17. And if the score was 50, this side would be true because 50 is less than 70. So as a result, we have true on the left, true on the right. This is true and that is true. So the overall result of the entire expression would be true. Let's look at the OR operator. We're testing to see if rate is not a number, if rate is not a number, or if the rate is less than 0. Okay. So for this entire statement to be true, either this left side has to be true or the right side has to be true. They do not both have to be true. So, and both sides have to be true, or one side has to be true. And then here's an example of we're testing to see if the age variable is not a number. If it's not a number, this would be true, but then the not in front of it changes that true to false. All right, some things you got to know. I've talked about these, an expression on the left, an expression on the right, but we can have we can have a chain of these. If age is 17 and score is less than 70 and birthday is in January, we could extend this out and have 3 or 4 or more operators included in there. And if that's the case, we need to understand this, the order of precedence for logical operators. So when we have multiple operators, this only has one logical operator, this only has one logical operator, This only has one logical operator. If we had more than one in the same statement, it's important to understand that there's an order of precedence, just like there's an order of precedence with our arithmetic operators. You think of PEMDAS, right? Logical operators, nots will happen first, then the ands get evaluated, and then the ors get evaluated. And just like in arithmetic operators, if we want to change the order that these get evaluated, so maybe we want to force an or operator to happen before an and, we can use parentheses. And parentheses, anything inside parentheses happens before the other things do. So we know what conditional expressions are. We've talked about relational operators. We talked about compound conditional expressions in this video. We've talked about the logical operators. We just discussed order of precedence, but we have not discussed the short circuit operator. So let's go back one slide to this. The short circuit operator for and or. What does short circuit mean? Short circuit, in electricity, means there's some kind of wire or some kind of path to ground that we didn't intend that makes things short out and causes fuses to blow and breakers to trip and things like that. Short circuit operator is basically saying we're doing multiple tests here. If one test invalidates the entire thing, we don't have to do the rest of the test. Okay, so it kind of makes the operation happen faster, flips that breaker, blows that fuse, however you want to think about it. So let's think about and. We said for an and, the left side has to be true and the right side has to be true. If I test the left side and it's false, and we're using an and operator, is there any reason to check the right side? There's really not, because both sides have to be true, and if the first one is false, I have no reason to test the right one. So a short circuit on an and operator would be if the first expression is false, it doesn't bother checking the right side of the expression, because there's no reason to. Because if this is false, the whole thing can't be true. A short circuit on an or operator. So an or operator, this side has to be true, the left side has to be true, or the right side has to be true. If I test this one on the left and it's true, well, I've met one of those conditions. I don't even have to test the right side anymore. Okay. So short circuit on an or operator, if this one is true, it doesn't test the right side. Generally, for early programmers, it doesn't make a big difference, but when you start doing things in your expressions, like maybe I want to put score plus plus up here, okay, so that after I do this test, 1 gets added to the score. Well, the problem with that is if I'm counting on that to increase the score by 1, and the short circuit operator never gets to test this, the score never gets increased by 1. So short circuiting can cause some pretty tricky bugs in your code. So it's important to understand that that happens. If there's no reason to test the second expression, then the second expression will not be tested. And that's short circuit operator. All right, that'll do it for this video.